Welcome to an exciting exploration into the vast world of numbers. What does it mean when we say a number is big? Is it 100, 1,000, a million? Today, we embark on a journey that takes us from the humble one to the astronomical infinity, uncovering significant milestones in between. Let's dive in and decipher the scale of numbers. Let's start with 1. That can be represented by the number of moons on Earth, or the number of noses most people have. 10. The number of fingers on 2 hands. 100. The approximate number of years in a century. 1,000. Roughly the number of meters in a kilometer. 10,000. The estimated number of steps a healthy person walks in a day, or at least should. 100,000. The approximate speed in kilometers per hour at which Earth travels around the Sun. 1 million. Roughly the number of minutes in 2 years. 10 million. The estimated number of stars in the smallest known galaxy, the Segue 2. 100 million. Roughly the number of books and other items in the Library of Congress. 1 billion. The number of seconds in approximately 31.7 years. 10 billion. The estimated number of stars in the Milky Way. 100 billion. The estimated number of neurons in the human brain. 1 trillion. The estimated number of cells in the human body. 10 trillion. The estimated number of microbes that live in your body, outnumbering your cells 10 to 1. 100 trillion. If you stacked 100 trillion pennies, the stack would reach from the Earth to the Sun. 1 quadrillion. The estimated total number of ants on Earth alive at any one time. 10 quadrillion. Number of integers that can be represented by today's computer in a double precision floating point format. 100 quadrillion. The number of grains of sand on all the beaches on Earth. 1 quintillion. The number of all the insects alive on Earth. 10 quintillion. There are 43 quintillion different positions of a 3x3x3 Rubik's Cube. 100 quintillion. The number of grains of sand on all the beaches and deserts on Earth. 1 sextillion. If you could count from 1 to 1 sextillion at a rate of 1 number per second, it would take you about 32 billion years, more than twice the age of the universe. 1 septillion. The number of raindrops in a storm covering half the surface area of Earth. 1 octillion. The number of individual hairs on all the humans on Earth. 1 nonillion. The Sun weighs about 2 nonillion kilograms. 1 decillion. A decillion dollars in a sphere would be bigger than Jupiter. 1 quindecillion. A cube of a quindecillion atoms would cover almost a quarter of the continental United States. 1 vigintillion. A sphere of 1 vigintillion gallons of water would be about 20 light years in diameter. That's the size of the Orion Nebula. 1 trigintillion. A trigintillion is about 10 trillion times more than the number of atoms in the observable universe. Okay, so it's getting pretty ridiculously big here. Finally, let's finish off with 1 centillion, a number 1 followed by 303 zeros. This number is so mind-numbingly big that there are not many things that we can compare to it. Consider the previous example about the number of atoms in the observable universe. Now imagine that each of those atoms was a mini-universe of its own. Then it would still take another billion trigintillion of these multiverses to have 1 centillion atoms altogether. We hope this journey from 1 to infinity has given you a new perspective on the concept of big, from the number of cells in our bodies to the number of atoms in multiple Earths. The scale of these figures can be mind-boggling, but hopefully our comparisons have made it a bit more tangible. As we conclude this episode, we encourage you to look at the world around you and contemplate the vastness and complexity of everything that exists. Remember to like, share, and subscribe for more insightful content. Until next time, let the vastness of our universe fuel your curiosity and thirst for discovery.